This cargo ship is carrying thousands of heavy steel containers. It weighs as much as a small city, yet it sits effortlessly on top of the waves. But if you take a tiny, lightweight penny and drop it into that exact same ocean, it falls straight to the bottom. It seems impossible that a massive mountain of steel stays up while a tiny coin goes right down. The answer lies in a specific shape-shifting change that happens beneath the surface. Floating isn't a matter of how light an object is. It depends entirely on how that object interacts with the water surrounding it. When you push a big beach ball underwater, you can feel the water resisting you. You are physically forcing that water to move out of the way to make room for the ball. That water wants its space back. It acts like a grumpy cushion, constantly pushing right back against whatever is taking up its room. This upward lift is called buoyancy. In this diagram, you can see the box's weight pulling it down, while the water's buoyancy pushes back up from underneath. An object stays on the surface whenever that upward boost from the water is stronger than the downward pull of gravity. This is hard for a ship because steel is incredibly dense. One small block of steel weighs as much as 8 blocks of water the same size. Because steel is so heavy, a ship must somehow create an enormous amount of upward lift to stay afloat. If you drop a solid block of metal into the ocean, it sinks instantly. Its compact shape doesn't move enough water to get that necessary upward lift. But if we take that exact same block of metal and stretch it out into a wide, thin bowl, the behavior changes. We haven't changed the weight, only the shape. This new shape is hollow. Looking at this ship under construction, you can see the hull is mostly a giant empty space filled with air. Even a massive aircraft carrier uses this wide, hollow design to sit on top of the waves despite its weight. Turning heavy materials into hollow shapes is the only way to make giant objects float. Because a hollow ship takes up so much physical space, it forces a gargantuan amount of water to move out of its way. Pushing away that much water creates a much stronger upward boost. The more water a ship moves, the harder the water pushes back to hold the ship up. This is why the penny sinks. The coin is tiny and solid, so it barely moves any water at all. Without that movement, it never gets enough lift to fight gravity. Submarines use this rule to go deep. When they want to sink, they pull water into their hollow bodies, making themselves heavy enough to pull below the surface. Success on the water comes down to a simple balance. You have to be large enough to push aside enough water to carry your own weight. Let's test what you've learned. What is the name for the upward lift that water provides? That's buoyancy. Second question. Why does a steel ship float instead of sinking like a solid block? It's because the ship is hollow. Final question. What must a ship move out of the way to create that upward lift? It has to move the water. You've got it! If you want to join us for more scientific missions, hit that subscribe button right now. Here is your recap. First, objects float when the upward boost from the water beats the downward pull of gravity. Second, giant ships stay up because they are hollow shells that move huge amounts of water. Third, small solid items sink because they don't move enough water to create lift. Try it at home. A crumpled foil ball sinks, but if you fold that piece into a little boat, it stays on top. Now you know how the biggest objects on Earth stay on top of the ocean. But how do the tiniest wires inside your earbuds create massive sound? Tap right here to see how that works.